Hello, I'm Kelsey, and today I'm going to be showing you how to find derivatives using the limit definition, which is also called the long cut because it takes a significantly larger amount of work than the power rule. Finding derivatives is important because it provides the equation of the slope of the tangent line, which gives you the instantaneous rate of change at a given point. It can also help find things like relative extrema, concavity, and many more important things. So the way we do this is by finding the limit as delta x approaches 0 of this, which is also called the difference quotient. So something special about this is that we can't exactly plug in 0 right away because then we'd end up with an undefined equation. However, if you remember with limits, if you substitute in the number and end up with a 0 over 0, you know that there's a way that you can algebraically manipulate the problem to get the actual limit and not an undefined answer. So the way that I'll show you that we can do that for this is by actually plugging in 0 for delta x in every part of this equation. So first, we plug in 0 here, and we get f of x plus 0 minus f of x, all over 0. Now, f of x plus 0 is the same thing as writing f of x. So then these two cancel, and you get 0 over 0, which is happy face because it means that you can somehow manipulate the problem to get the actual limit. So, a way to put this in perspective is by actually doing a problem. So, given f of x equals x squared, find the derivative using the limit definition. So, first things first, I'm going to write out just that the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, just to keep me on track. So something I like to do is break the problem into little parts so it's less intimidating. So first things first, I'm going to plug in x plus delta x for every x in the original equation. So in this case, it's x squared. So I'm going to plug in x plus delta x squared, and then I have to subtract x squared from that and then divide all that by delta x. So first, I can rewrite this as x squared plus 2x delta x plus delta x squared. Then I have to subtract x squared, so these two guys cancel, and then divide by delta x. Now there's delta x there that cancels, and one delta x there that cancels. So I end up with 2x plus delta x, but I'm not done yet because I haven't taken the limit as delta x approaches 0 yet, so I'm going to do that now. So limit as delta x approaches 0 of 2x plus delta x. So I plug in 0 for delta x, and I end up with 2x, which is the derivative of x squared. So now I'm going to show you a more difficult problem just so you can kind of see like a more difficult rendition of this type of problem. So here we have find, this is supposed to say f of prime of x, using the limit definition given f of x equals 4 over root x. So f prime of x is just another way of saying derivative. You can also write y prime and dy over dx. So here we're given f of x equals 4 over root x. So first things first, I'm going to plug in x plus delta x for the only x in the equation. And I would get 4 over root x plus delta x, then subtracting the original, which is 4 over root x. I'm just going to stop here because I have to do a lot more simplification because this just looks really ugly right now. So to simplify, I'm going to get a common denominator, and then I'll end up with 4 root x minus 4 root x plus delta x all over root x times root x plus delta x. Now, to simplify further here, I'm going to multiply by the conjugate, which is basically just a weird-looking one that will allow us to have a lot more simplification. So I'm going to multiply by the conjugate of this portion, which would be 4x plus 4x, or root x plus delta x, all over 4 root x plus 4 root x plus delta x. So when I multiply all this ugly stuff out, I'll end up with 16x minus 16 x plus delta x, and all over root x times root x plus delta x, 4 root x plus 4 root x plus delta x. So just to simplify things a little bit further, I can write this out as, this should be a little arrow, even though it is still equal. 16x minus 16x minus 16 delta x. So these two guys cancel. And I'm also going to take, you can see there's 2 4s here, so I'm going to distribute one of them out. So I'll get root x times root x plus delta x times 4, and then a little parenthesis, x plus root x plus delta x. Now here, since we have a negative 16 delta x on top, we can do a little cancellation with the 4 down here. And so you end up with a negative 4 delta x over, here I'm just going to rewrite it so it's more clear. It's negative 4 delta x over root x times root x plus delta x times root x plus root x plus delta x. And so now the next step is I have to divide this guy by delta x. So an easier way to do that is just to multiply by 1 over delta x. Now here we see cancellation. So now I end up with negative 4 over root x times root x plus delta x times root x. Oh, sorry, here I meant to say root x times root x plus delta x times root x plus root x plus delta x. Now I have to take the limit as delta x approaches 0 of this fun thing. And I'll end up with negative 4 over root x times root x times root x plus root x. So root x times root x is just x. So I have negative 4 over x, and then root x plus root x would be just 2 root x. So I have x times 2 root x. So I finally end up with negative 4 over 2x root x, which is the same thing as negative 4 over 2x to the 3/2, which is the derivative of 4 over root x. So that guy was very complicated, and something that I recommend if you get your delta x's and x's mixed up a lot is using a different variable than delta x, because you're more than welcome to use any other letter of the alphabet as long as it'll help you not get so many things mixed up. So another more applied version of this is this problem. It says find the slope of the tangent line at the point 0, negative 1, given that f of x equals x squared minus 1. Now there are 2 different ways to approach this problem, and I'm going to show you first the way that I prefer doing it is by first getting the derivative of that and then later plugging in this point. So first things first, we plug in delta x, x plus delta x for every x in this equation. So we end up with x plus delta x squared minus 1 minus x squared minus 1 all over delta x. So this part can be simplified as x squared plus 2x delta x plus delta x squared minus 1 minus x squared plus 1. So here, these 2 guys cancel out, and these 2 guys cancel out, and we're left with 2x delta x plus delta x squared with a little delta x underneath. So these guys cancel, and we're left with 2x plus delta x. Like in the problem before, it's similar. It has the same instantaneous rate of change here because there's just a constant out there. Anyways, so now we take the limit of delta x as it approaches 0. So we just end up with 2x. Now we're not done yet because we're given a point to find the instantaneous rate of change, and that x value is 0. So now we plug in 0 to this little guy, and we end up with, well, 2 times 0 equals 0. So therefore, the slope of the tangent line at 0, 1 is 0.